Let's do it. Welcome back, everyone. We have 2 talks until lunchtime, so if you want to do an early lunch, let's do it. The first talk is Robin Bensley, and he will be talking about co-designing a research AI GPU platform. Thank you.
Thank you. Kia ora, Rob Bensley toki ingoa. I'm going to take the challenge that was thrown down and do a waiata. So, yes, let's go. Te aroha, te whakapono, me te rangi mari e, te ato tātou e. We'll leave it there. That's good. Thank you. Thanks. Hey, look, so I've got quite a lot of material, so we're going to push on. What we're talking about is co-designing a research AI platform. So I do strategic projects at University of Auckland, and I was given a brief. We've got a research AI plan, which comes out of the strategy work we've done. Can you help deliver that? And it's like, oh, well, sure, we just design it. You know, you get an architecture diagram, draw some boxes and some lines between it. That sounds, pretty straightforward. Obviously, the reality is, University of Auckland has 13,000 researchers if you count the postgraduate students. Everyone has very broad needs. The AI space is very diverse. And so really when it comes to design, what are you designing? You know, really at that really early element, what does that look like? So what I want to do is take us on a journey, and this precedes even my involvement in the project, but really to talk about how have we started to get our thinking around the design for a platform. I just want to use the Stanford design thinking framework as a way of taking us through how we've gone on the journey. If you haven't seen this before, empathizing is your user. Can I understand the user of any solution? Do I understand what their needs are, what they're trying to achieve? Can I define the problems that they're trying to solve? And do I understand what are the boundaries and frameworks that we're going to work within? Can I ideate? Can I actually come up with the ways we could solve this and then prototype and test what that solution will look like? So I'm going to use that as a framework as we go ahead. So let's jump in. So, empathize. So actually a call out to the Centre for eResearch. They had started this process of pulling together researcher inputs of people who are doing AI, people who were facing the challenges of how they solve the AI problem. But there's also inputs from REANNZ and the HPC platform. And as I came in, I'm in digital services, we started talking to researchers as well. So we wanted as many diverse inputs and voices on the table as possible. I want to have a look at, I'll just share some of the data from that work, and for the statistical people in the room, and I know there are a few, hi Roy, and others, this of course is a small sample. It's greater than 100, but of 13,000 it is directional, it's indicative, it's not statistical, but it's useful. I hope so. Look, not surprising when we look at from a faculty point of view, well yes, STEM who have been using computing for empirical analysis, yes, they're early adopters of AI technologies and have a really clear understanding of where it might help or be involved. But what is interesting is the non-STEM, okay? There's AI projects that have been done with dance, with the business faculty, now starting with law and other areas. And so suddenly you've got digital skills and digital research across the whole. So how many data points could we have? We could have 13,000 really, because everyone is thinking about AI at some part of the research process. General up there is, that's thinking of things that are generic across. They're not specific to a particular faculty or they were consistent across faculties, like I want to do a literature search. The University of Auckland Library runs a AI literature search training. It's the most oversubscribed training they've ever run. It's like 300 or 400% oversubscribed. Not surprising, everyone's thinking about how do I use this stuff to support my research. But people are starting to think of it in terms of cleaning data, looking for anomalies in my data, to being involved in any data pipelines that I've got. And obviously, I've created a great model. How do I share that? How do I host that and make it available? And so people are worrying about all of those things, and those are kind of generic across. When we think of what types of AI, when broad AI, that's machine learning, deep learning, convolutional neural networks, things like that. There are a lot of different types of AI technologies being used, and of course, this is a snapshot. This data started being collected in 2024 and into 2025. If we did it today, maybe the Gen AI piece would be even bigger, and it was great at the plenary this morning for those who were there and awake, 3 coffees in. It's actually making a real difference. Gen AI is a tool to actually help find rare diseases. That was really exciting. But you know, still plenty of groups doing computer vision and these other parts of AI that have been around for a little while. When we look at that same data, but when we think about where does that sit on the research journey from I want to create a hypothesis, I want to do that literature search, but I also then want to do my ethics application. I want to do that data stuff, but I want to do some Python coding. Oh no, I've been given some Python coding, but I want to turn it into R coding. You know, people are starting to think and starting to use AI for all of these parts of that research process. The biggest blip there, obviously, is analytics. And there are, you know, whether that's Gen AI or whether that's these other methodologies, you know, research is in the process of trying to find those nuggets in the data. So it's not surprising that's where a lot of people are putting their efforts and thinking of how can AI help me in my research? Well, yes, that's that, and that is an amazing thing, but it's also a challenge. How do you create reproducible science? How do you create science that I can prove or put into a paper? You know, these are all challenges in the science world. And then obviously writing, collaborating. So, you know, you can translate your work in different languages. You can create containers of my work and share it. You know, all of these ideas are becoming more prevalent as we think about AI. On to the next piece in terms of defining the guardrails and the problems that we're trying to solve. Luckily, I came into the project and there was a rich set of, the university had put a whole lot of thinking involved into actually what is it we're trying to solve. So there is a whole University 2030 plan. There's a digital strategy talking about research, raising the bar of digital skills. There's an eResearch strategy right down at the nuts and bolts of what are we going to need to actually make a step change within the university, and within that there was a whole bunch of AI stuff, and that percolated out as a plan, and now I'm trying to land that plan. But when we think about the actual problem, you know, how does that translate? Well, it translates ultimately down to there's not enough GPUs in the whole country. We don't actually have enough resources for researchers to do the work they need to do. If you think about 3,000 researchers at Auckland University, and you know, Nectar have got some great GPUs, REANNZ have got some great GPUs, but they're in the tens of GPUs, and there are thousands of researchers just at Auckland University. So the problem is big, and so how are researchers solving it? By buying lots of these workstations. This is Bruce McDonald's robotics lab, and he cool lab. They're doing natural language processing, they're doing computer vision, they're doing machine learning, all sorts of different types of AI. But how are they solving it? By buying more and more and more workstations. They've got like 20, 30 of these, and their PhDs are running big cohorts with spreadsheets and who's going to use which machine on which day. Some of them are not busy at any given time. And this is an interesting thing. There are hundreds of these across the university, not all used in anger or regularly. There's so many GPUs around, but they're not all used, and that's part of the challenge. You know, what are the opportunities to optimize what we do buy and what we do have? So, what are our options to actually understand the options? Because the options is actually what we were like, oh great, we're going to go ahead, we're going to do this, but what options are there and what should we know? Well, we start with some knowledge. We all come with some AI skills and knowledge. I came out of being at Nessie and worked at an AI institute, but everyone involved have some level of skill and knowledge, including CR and REANNZ, and obviously the enterprise AI work that we're doing in digital services. But that wasn't nearly enough. So much bias that we have. Let's jump in deeper. We work with the vendors, NVIDIA, who have been here, plus the vendors, many of the vendors who are here in the room. We did a lot of work on where's the roadmap going, what are the tool chains. And hardware is one thing, but the software layer is so diverse. And so we knew we needed to do more. One thing we did, which I've never done before, I've done quite a few national procurements for New Zealand for high-performing computing, but this is the first time I've run an open procurement. And I wish I'd done it before. Amazing amount of interest shown, and we learned a lot about what the vendors could do, and we actually learned a lot about the technologies that people are starting to play with and use, and think about how could that work or translate for our researchers, and what difference would that make? And it just raises our knowledge. And then obviously as we step into choosing vendors, then you want people who are going to be partners and step with you through the journey. So if we start to go, oh, we've got all this information, we're going to start building a mental model for what this looks like. Yes, we've got a whole bunch of different types of AI. Yes, that's the end state of people we're going to serve. And obviously Gen AI is raising as a ever-present new capability that could be transformational for almost all research areas. In the middle, of course, what we're thinking about is buying some GPUs. So we're actually been through a procurement phase, but the software piece is quite interesting. So, okay, Kubernetes, Linux, which is Ubuntu, and vast storage. The storage piece was already at the university, and so how do we link all of this together? So thinking about how do we build a cohesive piece. And then on top of that, this is where we're going, okay, we've got AI models. Are we going to have loaded models like DeepSeek or Qwen or these other cool models? Which ones are going to be most useful? How will those services look like? Do we leave it all up to the researcher and we just go, it's bare metal, we're stepping back, good luck, hope it's fun? Or do we help them in that process? I think that's probably where we are, and agentic work is, we're at the cusp of that, and that's where I think there's a lot of opportunity. And then when we go, oh great, we're going to build it, but somehow we've got to link it back into everything that's already in the infrastructure world or in the university, and we've got to work on how to do something with that. There will be some announcements coming out, so I don't want to spend much time on it, but I just want to call out that we did make some choices for where we're going. Not surprising, NVIDIA GPUs that we chose, and we've got in our roadmap for our investment strategy, which steps over 5 years. Hewlett-Packard for the servers that we are working on, and ASI Solutions for everything above, including helping run the cluster. So ASI has become a critical partner for us as we go forward. Interestingly, we had assumed when we start we were going to stick this in our own data center, air-cooled, we just buy a few servers, stick them in a rack, all good. But then as we go, our 5-year strategy, by 2026 we'll be up to 100 kilowatts. Oh my goodness, that's, we could spread that over 3 or 4 racks, or we could stick that in one rack and liquid cool it. And it was like, we don't know how to liquid cool it. So we've partnered with CDC, and we're sticking this equipment out there and in Hobsonville, and that's where we will be running the vast storage, the compute, and running the whole platform from there. So a changing time, and I guess that's as we go through procurement. You have to think about being able to adjust. Prototyping, this is an important piece of the puzzle where we're going, what what software is going to make the most difference, or what parts of the puzzle will make the most difference. And there's a whole bunch of things being played around with, both with ASI and ourselves, and even in CR, different tool sets being played with, and those actually give us a rich set of inputs and ideas of the things that might be useful, and more to do there as we start to net out those actual design pieces that we will put into our final platform. In terms of testing, when we were going through the process of thinking about GPUs and what GPUs, we did get these test versions of, NVIDIA have a whole platform that they offer access for GPUs for testing and trial, and we did benchmarking. We took actual researcher codes and we ran them on the platform and then tried different, between the REANNZ GPUs and what ones were available, and that way we could start to understand what impacts there were by choosing different GPU. But there's a whole bunch of researcher stuff that we need to test in terms of that prototyping we're doing, and that's kind of where we're at. So let's just quickly go into some lessons learned. I think it's probably true we could have been better at breaking down the silos. We did try to bring the cohort together. It's a big, complex organization, but we've done the best we can, and obviously we'll work to make sure that that's even better as we go forward. I think we can't underestimate the fact that we've got to keep talking to the researchers, and that was not a one point. The Stanford looks like a piece, and I purposely put it in a circle because I think it is iterative. We will have to keep talking to researchers as we go through, because the needs are going to keep evolving. The landscape is evolving. We've got the MBIE research platform coming through, and all of these different inputs and ideas that will inform what we might need to do. I think being curious is a really important thing. How do we keep looking for what options there are, and not being constrained by our bias, and working with partners who have the same values and are going to go on that journey with you. I think that's pretty important, because we don't exactly have everything buttoned down. I wish we had those boxes and lines at the beginning, but we're starting to put more boxes and lines in place as we go. And I think getting started is just an important point. We've got to actually do something and get going, and not wait for the perfect solution. We want to get some usage and get something out of this investment and put it into the researchers' hands, so we get value right from the beginning. And I don't know if you've seen, all the price changing happening in the market, but being ready to change is going to be important, and this will be an interesting year. We had planned for quite a big investment. What that looks like as we go into this year will be interesting, and we're going to have to be nimble and creative, and that will be where we're going. So that's me. That was a quick run through. It's a work in progress, but it's worth sharing, because everyone's trying to solve similar things. So, any questions?
What sort of questions did you ask the researchers when you were figuring things out?
Yeah, it's an interesting one, because it wasn't really so much about a survey or anything like that. It was lots of conversations. So I guess it wasn't necessarily linear, but we've captured what their research outcomes were, what methodologies they would use, and I guess what the gaps existed and what we could help solve. I think there's probably a richer set of questions that could be done, and maybe that is a good next step for the larger cohort to dig a bit deeper. Marcus.
Yeah. So it seems always, and this is from my limited view, is that strategies take forever to be formed. The business cases, they lag, take 12 months almost to get done, and then it's always the very rushed process under intense time pressure at the very end. Now, if you had the luxury of setting the timeline yourself, how much before procurement would you start the process?
Yeah. Look, I joined the project in sort of September, and we found out in October that the university had some capital that were available to spend, and so we pushed really hard to get that done by the end of the year, end of the financial year. So it was an intense pressure cooker. The reality is we didn't spend enough time with both researchers on that wider view and also with the vendors, you know, because, I mean, we had vendors respond that we didn't even know existed. And it's like, you've got great skills. We don't even know what you can do. And so it was a journey that we went through under a pressure cooker. And it's fine. We've all done cramming the night before exam. Amazing things can happen. But the reality is, you know, more time would have given us ability to dig a bit deeper and to perhaps get to a procurement where we had more certainty around certain elements. Anyone else? If not, thank you so much. Oh, yeah.
This is a GPU-based platform for AI. There are researchers out there who are using GPUs to just accelerate their code. Are they going to be allowed onto this platform if they're not using AI?
No, we want to keep this specifically for AI research, so AI methods, and likely there will be some tailoring towards specific services maybe over time. But you know, we're not trying to compete with REANNZ. You know, REANNZ is the national provider for wider compute and simulation and modelling. Is the home of that is on REANNZ. So we're definitely looking specifically at the pieces that they're not doing, which is container-based AI research.
Please join me in thanking Robin. Okay, our next talk is Joshua Duley, Progressive Development Environments, Scaffolding, Computational Competency in Research Teams. Cheers.
Yeah, I wrote this, how close does it need to be? I wrote the title 6 months ago and then had to figure out what I was talking about more closer to it. My name's Josh Duley. I'm a data scientist at the Hugh Green Technology Centre. We're nested within the Malaghan Institute of Medical Research. And data science is a support team within a support team there. And we're fairly new on the block. The team started 2 years ago with our team lead. First person to come on board was DevOps and really trying to get some of the groundwork laid, get people's work stable and scalable. And then we've slowly grown the team from there, where we're trying to both build tools, onboard tools, find third-party tools that people want to be using, as well as supporting staff members in the other support support teams and core facilities, as well as researchers. At the Malaghan, we've got a lot of master students, PhD students, postdocs, researchers of varying flavors, where everyone's coming in from a different place and different experience. And as a small team, we're really trying to maximize our impact, either by providing direct service or putting people in positions where they can self-serve and go after their own research goals with as much hands-off from us as possible. To that end, very broadly speaking, we sort of identify 4 user groups. The no-code users who still want to be running some analysis and they just want to point to the data and push play in default conditions. We have the code curious, people who are both wanting to learn a little bit more about programming. They're generally going to be using pre-configured analysis pipelines. They might be tweaking a few parameters, but they're generally treating things as grey boxes. I've got experienced grey box. That was a typo. It's not supposed to be there. Experienced users, they're going to be writing more bespoke notebooks. They can self-configure their notebooks. But quite often they might still have some parameters hard-coded and not have the best software engineering practice in place. And then sort of expert users who are going to be using a balance of working in notebooks, working in IDEs, using GitOps, and really getting towards more robust software practice. And so we're sort of trying to slowly draw people further and further down this table and upskill, and the further down this table people are, the less work we have to do administratively helping them along the way, but at the same time providing that as a service. And then if I run out of time, this is my talk in one, where these are sort of our high-level tools that we very rapidly wanted to make available to ensure that they were stable, scalable, that people could be running simulations and analysis on server and connect to our GPUs in a stable, timely fashion, that they were all sharing things nicely. And so that's why we started off getting DevOps on board, so that we could just get our foundations set and make things available. And that was very successful. Things were available, but then there's still that element of, so my term scaffolding, really helping people along that journey so that they can make the most of the platforms that we've been able to set up for them. And so lots of educational efforts. It's not formally within our remit, but we've sort of come to the conclusion that if we want to really get people down this line, we really do need to be providing educational support. Running regular data demos, so that's quite often when somebody has a result or a pipeline that they're really excited about and produce, then having a user group that they can talk to and discuss this. Public code reviews, really getting into specific details of code that people have written, that we can critique one another's work and really collaborate on what people are working on. Ad hoc support at any level, really wanting to be available to people for, hey, I've run into this headache either with setting up my environment or in a bit of code that I'm trying to write or a library, can you help? And then group workshops, 1, 2, 3-day workshops where we bring people on and give them a course in Python or a course in R and try and support them there. And then, so this is sort of the next layer on top of just giving provision of the environments, but we wanted to go a step further and see if there was a way that we could architecturally establish some tools that coerced, encouraged, pushed people towards a more sophisticated software engineering workflow, the way that they were operating, without necessarily needing to overtly coerce them into that, or without needing to run extensive training, but have that a natural way that people were going to be operating. Specifically, what we're trying to avoid is what I call a notebook plateau. You get people running, they can write some code, they can write some scripts, they can run them, but they get stuck writing notebooks. And so the parameterization, the data, the code, it all gets stacked in one layer. It's very difficult to disambiguate. Apologies if anybody was on this paper, I don't want to be too critical. Everyone came out the other day, lots of people in the office really excited about it. I'm a data scientist, so I went and looked at the repo and said, hey, what's going on under the hood? Maybe it's something we want to reproduce. There were 2,300 notebooks. The orchestration was by implicit nested folder structure, telling you which way to run them. And it was a mess. And so I sort of did a bit of quick QC through it. After removing all the executed notebooks, we were down to 550. Course parameterization and trying to functionalize some of them at a very high level, I managed to get it down to 114. 85 of which were analysis steps. There was some figure generation, table generation, and result exports. And essentially my take was that the original presentation didn't meet my threshold for scientific reproducibility. Technically, the result was there, but you had to read all 2,300 notebooks to try and figure out what was going on. It's just not something that's actually a reasonable expectation when you're publishing something. And so trying to encourage people to use notebooks appropriately. Notebooks are great, I'm not discouraging that, but for that not to be your final 2,300 things presented. ASCII diagrams for keeping it simple. The view is to really separate domains in which people are working, and so that almost enforces some structure that we're looking at it. And not to say that the individuals on the bottom are different individuals, they're just different hats for people to be wearing. And so starting from the left, if people are doing software development, research software engineer type hats, then they're contributing to the code base, which is stored in Git repos. And we're collaborating on repos, and we all have exposure to one another's repos, and they're accessible. And then that will be passed into an execution environment, which could still be a notebook. It could be that you're importing a package and running functions in it and working there. But it could be a third-party app, or it could be some in-house apps that we're developing. Your data, is stored on server. People aren't running around with data on their laptops, on hard drives, various cloud locations, but it's all in one place, but that our analysis environments have a view to it. They can query a database of available data, draw it in, and then run analysis in that space. And for completeness, I've got an instrument and wet lab scientists down the far end, because that's where our data's coming from. And so not necessarily are these going to be different people. I'm not a bioinformatician, but sometimes I put that hat on to help people out. Our bioinformaticians are often doing a lot of development. They're often doing some DevOps for themselves, setting up environments. So it's a very fluid space there. But explicitly stating that, okay, these are different domains of work, and by separating them out in your mind, it gives a much more robust way to document your work and to get yourself to publication. So I'm going to use a little bit of a case study of an app we've put together, mostly looking from the no-code user perspective, but hopefully we can see how that cascades down or up, which way you're looking, into more advanced users. Getting a GUI interface for no-code operation, some defaults that people can just select their data and run. That can be worked up to mutable pipelines, so people can change operations, change parameters, they can tweak it, but still in a GUI no-code environment. So that gets down to, it's not code curious technically, but people who want to gray box things a little bit and actually look at what's going on. The underlying asset base is still in our Git repo. So the advanced users can still contribute to that, they can query that, and they can work in that space. But when people are running analysis, it's in the app, and it's in that analysis space where you've got static methods and parameterizations that you're calling upon. You're not simultaneously trying to write code and then immediately run your analysis in situ. Establishing coding standards. So we can say to people, hey, we're doing some functional programming here. If you write your code in this manner, then it's going to be very easily integratable into the apps that we provide. And they're not saying you have to do this, but if you do it, is the benefits that we can provide. And then opening that up for people to contribute to, so that everyone isn't running with their own repos and their own little silos and nobody knows who's working on what. If there's a few people working on similar projects, we want them contributing to the same repo, which is then read into the app. And so working towards clear separation between the different domains. So running through a few tabs in the app, we have exposure to our experiment data. We've got a database with a lot of this is mostly single-cell data that people have sequenced. It's available, you can select the data, you can do some basic inspections, but it's presented to the user. They don't need to go away and find it and manage it. It's all handled for them. We are simultaneously doing this because, again, AI tools, people want to start querying historic data. It's very expensive to generate, and if we have it well documented and in a database, then we can query historic data to rerun novel analysis on. Mutable pipeline. So we've got a code base of assets that have been reviewed and approved and sort of drawn into our standard library and contributed. There's an explicit statement of parameterization, and at this stage, your algorithm is set, and you can call upon it. You can orchestrate your pipeline, sort of clear order of operations. You can select certain ones, change the parameterizations. You can do sub-wrappers and subclusters, and really have an analytical mindset when you're actually coming to analyze your data. And then visualization tab. So you've run a pipeline, you look at the results, you can have mutable figures. This is clustering diagrams, so you can subcluster, you can select certain things, you can inspect your data, iterate back to your pipeline, hey, it didn't quite work out, and have this very rapid process of going back and forth between visualizations and pipelines. And then the most important thing in this process, as far as I was concerned, was the documentation of this. So all of the pipelines and all those figures are packaged into a report where you've got a shareable JSON file that you can send to your collaborators, you can version, you can document, and you don't need to carry all of your data, you don't need to carry all of your figures. You've got an explicit statement of what it is you did. Not strictly human readable. It is human readable, but it's designed to be machine readable but shareable, where essentially you've got a JSON file which says this is exactly what you did in your pipeline, this is exactly what your parameterization was, your order of operations, here's the report you generated. You can send that to one of your collaborators, they can jump in the app, they upload it, and hey, they've got your pipeline, they've got your figures, they can iterate on it, they can get the new bit of documentation, and you can proceed like that as a group of collaborators. And then when it comes time to publish, we can apply, again, all sorts of tools to translate your machine-readable JSON into, hey, here's a paragraph, here's a set of paragraphs saying exactly what you did as part of your research journey. We're looking to layer some LLM support on that. A big thing in this space is making sure you've got deterministic outcomes. And so we're looking to have an LLM layer sitting in between our deterministic code base, so that if you're a low-code user, you can interact with the LLM to construct a pipeline and query what's available, and that'll be inspecting the documentation on each of the operations as a context base. As well as, we're not quite there yet, but we've sort of got some exploratory work with knowledge graphs and vector databases on the literature, so that when you get a result, you can query the relevance of certain genes or certain groups of genes, and have that as a conversation with the literature through the LLM. There's some third-party tools that we're looking at possibly APIing into, which might make it easier than us actually building these databases ourselves and doing this training. But it's an interesting space, and people want it, obviously. Anyways, very quick run through. I don't know where I am for time. I make some acknowledgements. In team, Axel McKenna has been a summer student with us for the past few months. Has been absolutely phenomenal. If you see his CV, you should hire him. Christian Hagelin doing all of the DevOps. Some bioinformaticians doing some QC on how we're processing things and working, Sam and Olivia. And our Malaghan IT team, who manages all the hardware, and pretty much we're air-gapped and they let us do whatever we want on the server, which is absolutely phenomenal. The organizations making this possible, Hugh Green Technology Centre, the Hugh Green Foundation that funds us, Pahuro Charitable Trust that funded Axel for his studentship, and of course the Malaghan Institute. All right, thank you.
Questions for Joshua? What's the incentive for the researchers to improve their computational competency?
So for a lot of them, there's a personal desire for just professional development. People want to be able to broaden their set of skills. Many of them having a background as wet lab scientists, but want to at least to be able to understand what's happening programmatically, all the way through to wanting to be writing or contributing to bioinformatic tools.
That's wonderful.
Yeah.
I just find they're usually a bit overworked. They want to publish papers, they don't want to publish on GitHub.
Yeah, no, they're a lot overworked, and it's a real point of tension. And so a lot of this provision is trying to say, okay, here's different ways that for however much time and wherever you're at, you can engage with the process. One of the hardest things about people learning programming is they need a project, they need something they're working on. Getting started from zero is really tough there. But if we say, hey, here's a pipeline, here's something that you can run, take an interest in just one operation, like a very small tranche of what you're doing. Most of the operations are 10 lines of code, including some library that we've called on. Let's look at that, see what's happening, make some changes. You want to write a figure, and we can get them contributing at that level without them needing to understand the whole pipeline, what you're doing every step, and really break that down into digestible chunks. So, yeah.
Thanks, that was a great talk, and really cool to see New Zealand institutions putting that rigor and process into the science. I think that does support reproducibility and all those things. What are the opportunities for alignment and sharing outside of your organisation with, there's so many genomics groups, all must be grappling with the same things, right?
Yeah, and this is a tough problem. There's for every genomics, not quite this bad, but for every genomics group, there's a different way of people running genomic pipelines, and for every standard, we get N+1 standards. At least from what we're putting together, we've built here, we're hoping to, at the very least, get this published, get open source provision for it so that we can share what we've done with people externally. The exciting thing for me is I'm not that precious about the coding standard. It's a standard. The important thing for me is working towards one where people from across our institution, but hopefully long-term externally, it's like, hey, if we're running genomic pipelines and everybody writing them in a consistent fashion, then we can start contributing between institutions and between research groups. We're not looking to necessarily replace things that are out there. Nextflow is an excellent provision. All right, so there's a bit of tension there. And so one of the things that we tried to achieve with this is permitting people to still write just Python native. And so one of the issues in complex pipelining solutions is you need quite an in-depth understanding of what that architecture is in order to be able to contribute. And so the way that we've structured this is you don't even need to use the app in order to run any of the steps. You can just import the package, run a function, and it will go. And so when people are contributing, they only have to know how to write 10 lines of Python. And the app can ingest that and pick it up and run. And that, again, looking towards trying to foster people to actually engage and new coders to engage. There's probably a very good argument. This is not the, I'm not trying to compete with big software engineering developing houses and large development teams who will undoubtedly be able to do a gold standard software engineering solution here. But there's this space in the middle that we weren't able to get people to jump all the way from zero to software engineers. And so hopefully we're providing a platform and a solution and a way of operating that bridges that gap. So I roundabout there. I have. Yeah.
Thanks for the talk.
Cheers.
So I saw that there's a JSON export option.
Yes.
What's kind of the plan with that file? Because I guess I can imagine you could generate a complete reproducible set for set of code and publication based on that JSON.
Yeah. Yeah, and so my vision for it, first as part of a research project, ideally that is actually also being contributed to a repository and people can version that JSON, that record of what's being done. At the end of the journey, I'm doing some work with LaTeX and various outputs to be able to interpret outputs in the JSON to actually just standardize human reading paragraphs of, hey, here's what we did, here's the repo for each of these operations, here's where it all is, and have a very concise methods section that surmises what you've actually analytically done as part of the process. Not for that to necessarily be, ideally, that's just straight to publication because it's going to be phenomenal, but at least have a starting point for researchers to say, hey, human readable, here is what you did with specificity, with connections to packages that you've used. Instead of, again, non-software engineers, PIs, senior researchers trying to bridge that gap, sort of taking care of that for them.
I think it's lunchtime. Thanks for coming, everyone.
Cheers, thank you.